In this lesson, we're going to cover SnapMirror Data Protection Mirrors. I gave you an overview of what they are in an earlier lesson in this section, and this slide is taken from there. So I'll put it back in here again to summarize our DP mirrors before we talk about them in more detail. Our data protection mirrors can replicate a source volume to a destination volume in the same or in a different cluster. Typically, we'll be replicating to a different cluster. They can be used for the following reasons: to replicate data between volumes in different clusters for disaster recovery. This is usually the main reason that we use our DP mirrors for. When you are using them for disaster recovery, intervention is going to be required to fail over to the DR site. We can also use them to provide load balancing for read access across different sites, for data migration between clusters, to replicate data between SVMs in the same cluster, or to replicate data to a centralized tape backup location. And when we talk about SnapMirror in general, we're talking about DP mirrors. So the first and the best known reason for implementing data protection mirrors is for disaster recovery. We've got a main site that we're using as the active site for our data, and then we're going to have a standby disaster recovery site. And we're going to use DP mirrors to replicate from the source side into our destination at the DR site. When we do this, we'll usually use inexpensive SATA drives on the DR site. Maybe in the primary site, we're using SSDs or SAS drives. To save money, we can put in less expensive drives in the DR site because it's just sitting there as a hot spare. This is a management decision though, because if you do that, if you do have to have a failover, you're going to have a performance hit while you're failed over to the DR site. If you want to be able to maintain the same performance during a disaster, then you're going to want to put the same types of disks in both sites. The next reason we mentioned was for data migration or for read-only load balancing. If we're doing read-only load balancing, this is where we've got a writable copy at the source site, and we have got read-only copies in other remote sites. When we do this, if it's read-only data, let's say that our main site is in Singapore and we've got another site in KL. We can have the Singapore site as a writable copy, and we can have KL as a read-only copy. Let's say we've also got a read-only copy in Sydney as well. Now what we can do is that users who are based in Southeast Asia, who are accessing the data, can be directed into the Singapore or the KL site, and users who are based in Australia will be directed into the Sydney site. So we're going to give them the lowest latency access based on where they're actually accessing it from. So it gives us disaster recovery solution as well, because we've got the data in more than one site, but it also gives us load balancing for our read-only data. So it's kind of like building your own content delivery network. Another reason we can use DP mirrors is for data migration. Like if we had some data that was in Singapore and we want to move it across to Sydney, we would use DP mirror to do that. And the final reason that we're going to cover here is for staging to remote tape. So in the example here, I've got multiple remote systems. I'm replicating them all into a central site where I've got my tape devices, and I'm going to back them up there. This saves me having to buy and to manage tape devices in each of my different sites. Okay, let's look at how we're going to configure this. So we need to do the initial configuration steps. We covered this in an earlier lesson. So license add to license SnapMirror on both clusters. Then we also need to configure intercluster logical interfaces on every node in both clusters. After we've done that, we can then peer the clusters. We also need to peer the SVMs as well. Next, we're ready to create and initialize the volume mirror relationship. These commands are all done on the DR site. So after we've created an SVM, we need to create a volume to replicate the data into. The command for that is volume create. Here, our vServer on the destination side, we've named it Department A DP. We create a volume of volume 1 DP that we're going to replicate volume 1 from the source side into. We've put it in aggregate 1, said size 100 gigabytes. When you create the destination volume, it needs to be at least as big as the source volume. And then we say type DP. This says that it's going to be used as the destination for a SnapMirror relationship, and it makes it a read-only volume. Next, we create the mirror relationship. The command for that is SnapMirror create. The destination path in our example here is Department A DP : volume 1 DP. And the source path is Department A : volume 1. We say type DP for a data protection mirror, and we configure the schedule here as well. In our example, we are using a 10-minute schedule. When we put the SnapMirror create command in, it creates the relationship, but it doesn't actually replicate any data across yet. So we need to do that next. To do that, we use the SnapMirror initialize command, and we can specify just the destination path. I don't need to put in the source path as well, because on the destination volume, we can only replicate one volume into the destination. So when I specify the destination path, it knows what replication I'm talking about here. So we do that, and it will do the initial baseline transfer into our destination volume. And that initial baseline transfer is going to be done over the network. Now, incremental updates of snapshot copies from the source to the destination are feasible over a low bandwidth network connection. However, if we try to do that initial baseline replication, if we've got a lot of data in the source volume and we're trying to send that over a low bandwidth connection, that could take a long time. So alternatively, we can perform a local backup of the source volume to tape and then physically shape that tape over to the destination site. The mirror baseline initialization is then performed by restoring from the tape at the destination cluster. So this saves us having to do it over the network. Tape seeding is supported for both DP mirrors and for SnapVault as well. Okay, so at this point, we've got our SnapMirror relationship set up and we are replicating data based on our schedule. Let's say that after we've done this, we do actually have a disaster. We lose the primary data center and we want to fail over to the DR site. To do that, again, all the commands are always done on the destination side. So in the DR site, the first command we put in is SnapMirror KS and then specify the destination path. What the KS does is if there's a replication that is currently running, it will allow that to complete, but it disables any future transfers. Next, we do a SnapMirror break to break the SnapMirror relationship. When we do this, it's going to make the destination side a writable copy. So when we do this, if the primary site is still actually online, then we want to take the source volume offline at the primary site to stop anybody making any changes there, because the DR site is now writable. We don't want people making changes to both sides, because then we'll get inconsistent copies of the data. They're not going to be the same. So take the source side offline when you do this. The other thing that you're going to need to do is you're going to need to redirect the clients to point at the DR site now. It's going to be on different IP addresses, so you're going to need to direct them there. There's various tools you can use for this, such as GSLB, Global Server Load Balancing. That is not a NetApp solution. That comes from network vendors like Cisco and F5. As well as directing clients over, there's other settings that you're going to have to take care of as well. Because SnapMirror replicates the data, including file level permissions, to the destination volume, but it doesn't replicate the data on tap settings. So to fail over to the DR site, as well as doing the SnapMirror commands, you're also going to need to make the destination volume accessible to your clients. So you'll need to mount it into the namespace. You'll need to create CIF shares and permissions if it's using CIFs, NFS export policies if it's using NFS, and your LUNs will need to be mapped to the correct iGroups after failover if you're using SAN protocols. So those tasks are all mandatory for the clients to be able to access and use the data. Other things that you should do are assign snapshot schedules and assign storage efficiency policies. So those tasks, you can do them before the disaster to save time if you do have to do a failover. And the other thing you need to do as well that we mentioned on the last slide is redirect clients to the new destination. Next thing that we're going to cover in our scenario is test recovery. So let's say that we did a failover, but we didn't actually have an actual disaster. We just wanted to test that disaster recovery works. So we did the failover with the SnapMirror commands that you saw on the slide previously, and we'll write some test data into the DR site and check that everything works. Once we've completed the test and it's been successful, we can then fail back to the primary data center. To do that, we use the command SnapMirror resync and specify the destination path. Again, this is done on the DR site. When you do this, any new data that was written to the destination, to the DR site after the break, is going to be deleted. It's going to be overwritten with what is on the primary data center from before you did that initial break. So only do this if you don't care about losing that data. For example, you were testing DR and you just wrote some test information into the volume that you don't actually need to keep, or if you actually did have a disaster, if this particular destination volume is just used for dev test and you don't care about actually retaining any changes that you made to that volume while you were failed over to the DR site. The next recovery scenario to cover is if you do need to restore changes to the recovered site. So this is where we actually had a real disaster at the primary data center and we failed over to our DR site. So let's say the primary data center was down for a week. During that week, we've been making changes to our volumes in the DR data center, and we now want to fail back to the primary data center again when it comes back online. Well, to do this, we're going to need to replicate those changes over the last week from the DR data center back to the primary data center. And to do this, we're going to need to reverse the direction of the SnapMirror relationship. So to do this, the first thing we do is a SnapMirror delete, specify the destination path. Again, all these commands are configured on the destination side, so this is on the DR side. Now we're ready to reverse the direction of the SnapMirror relationship, so we're going to create a new relationship on our primary cluster with the DR as the source. Our commands are always done on the destination side. The primary data center is going to be the new destination now, so these commands are done on the primary data center. So on there we do a SnapMirror create. The destination path is now going to be Department A Vol 1 in the primary site. The source path is going to be Department A DP Volume 1 DP on the DR site. And we say type DP again. Then, if we were doing the initial setup, the next command would be a SnapMirror initialize, and that does the initial baseline transfer. But we don't need to do that here because we've still got the snapshots on the primary and the DR site, so we can use those to just replicate the incremental changes across. To do that, again on the primary site, we do the command SnapMirror resync and specify the destination path. This will now replicate just the incremental changes from the last week that happened in the DR site back over to the primary data center. So we don't need to do a complete rebaseline again. When that is done, we've now got the current copy of the data in the primary data center, but our problem now is that the disaster recovery site is the writable copy and it is replicating to the primary site, which is read-only. We want it to be the other way around. We want the primary data center to be the writable copy again. So to do that, we need to break the SnapMirror relationship again. So again, on the primary data center, because it's currently the destination, we do a SnapMirror keyS, a SnapMirror break, and a SnapMirror delete. Then back on the DR site again, we're going to reverse the direction again, back to running from the primary to the DR site. So on the DR site, we do a SnapMirror create. The destination path is going to be on the DR site now. So that's department A DP, volume 1 DP. The source path is in our main site. So that's department A vol 1. The type is DP, and we're going to configure a schedule of 10 minutes again. Again, we need to resynchronize the relationship. We don't need to do an initialize because we've still got the snapshots there, so we can just do the incremental changes. So the command is SnapMirror resync again. Once we've done that, we're back to how we started. The primary data center is the writable copy, and we're replicating to the disaster recovery site, which is the read-only copy. Okay, last recovery scenario to cover is if the original volume is corrupted or destroyed. So say we had a disaster at the primary data center, like we had a fire there and we've actually lost all our hardware. Well, in that case, we're not going to be able to do a resynchronize because we've lost the disks, we've lost the snapshots. So we're going to have to reinitialize the baseline in this case. So the order of operations would be to get your replacement storage system in the primary data center, do all the initial configuration on there, and then create a new volume on there. Then create a new relationship with the disaster recovery site as the source, initialize the mirror. We're going to have to do a new rebaseline here, and then reverse the SnapMirror direction after this when we want to make the primary data center the writable copy again. Okay, last topic to cover in SnapMirror DP Mirrors is SnapMirror for SVM, which is a new feature. SnapMirror for SVM creates a mirror copy of the data volumes and the configuration details of a source SVM on a destination cluster. So this is an improvement of our normal data protection mirrors, which just replicate the data and the permissions across. Because as we covered earlier, if you do that, if you do want to fail over to your DR site, you're going to need to configure all of the NetApp settings on your DR site before clients can access their data. When we use SnapMirror for SVM, this is taken care of for us. So with SnapMirror for SVM, you protect the SVM's identity and namespace, not just the data volumes. Setup for this is quick and simple, and storage at the secondary SVM is provisioned automatically, and any configuration changes you make after the initial setup will be automatically replicated to the secondary SVM. There's a couple of different ways we can implement this. First one is identity preserve mode. When your primary and secondary SVMs are on the same extended layer 2 network, like if you've got dark fiber between the sites or if you've got a layer 2 MPLS VPN, then you should configure SnapMirror for SVM to use identity preserve mode. Both SVMs will use the same network services like DNS and Active Directory, and if there's a need to fail over to the DR site, the secondary SVM assumes all of the configuration characteristics of the primary SVM, including the IP addresses of the lifts. So this is going to be very convenient. You don't need to reconfigure anything on the destination side, and also you don't need to reconfigure your clients either because they're still pointing at the same IP addresses. When you do a failover, the secondary SVM will effectively assume the primary SVM's identity. Both SVMs use the same SIF server machine account as well. Now with this solution, obviously if the second SVM is going to assume the primary SVM's identity, including its IP addresses, this is going to be an active standby solution. We couldn't have them both active at the same time because we would have conflicting configuration there. The other way we can configure SnapMirror for SVM is identity discard mode. When your primary and secondary SVMs are on different subnets, configure them to use this identity discard mode. Here, the primary and secondary SVMs use different network services such as DNS and Active Directory. The primary SVM's data and namespace are still replicated to the secondary SVM, but only partial configuration data is preserved. So we're not going to copy everything across there like IP addresses and things like that. So this will require some reconfiguration when you need to do a failover. Clients access the preserved data through different network paths when you do a failover.